Hello guys, welcome back to my channel. Today we're gonna solve again a lexicographical order problems from Leetcode. It's medium one, and the statement gives us an integers n, and we need to return all the numbers in the range from 1 to n, sorted in lexicographical order. For example, 13. We're gonna return 13 element like this. 13 elements like this. Um, you can see that on the numbers start with 1 must be in front of numbers start with 2, and numbers start with 2 must stand in front of numbers start with 3, and so on. That's right. uh, that's mean that's mean like for example, and like thousand like that this, and the number start with 1 must be stand before, like until you go to 200. But now it's gone, and so on to 13, so on. That's right. mm. And for example, this we got 10, and we got the maximum, which maximum, so we're gonna count this and this to this and this. But actually we must write 11 first, right? Because this is smaller if the prefix up to numbers is the same. So which is smaller in the length stand in front of the other. So we can got something like this, and continue to so on to reach the maximum. And after reaches, we're gonna move back to 2, and so on and so on. So as you can see, the thing that makes this problem interesting, that is, you must write an algorithm that runs in ON time, but only use O1 extra space. That means you must use a constant memory variables. Mm, if not, just short it in order of string in the lexicography order is using quick short or something like that with the n log n. It's quite simple, so we're gonna show this with this requirement that's make this problem more complex and like difficult. So the idea here is you try to you need to do with numbers start with 1 first, then move on to 2, and move on to 4, 3, and so on. And in, like for example, let's consider about the number that start with 1. Like when we put 0 to the back, it's always smaller than put 1, right? So we try to put 0 to the back. That means multiply by 10 until you reach the maximum limit. That's the end. And then you just increase and increase, +1 +1 +1 until you got you end with 0. You got the number that end with 0, so we must divide it. We must remove the 0 and to get the number that's smaller in the lexicography order. As I demo here, you're gonna increase from 109 to 110. But actually you must remove the last 0 to got 11, that is smaller, and then keep going with the 10, and so on. So let's take another example, like 1000. We're gonna from 1 to 10 to 100, and 1000 and 1001, and keep increasing until you got this, right? But actually you want to put this in front of this, and then multiply by 10 again, and keep going to until you make this, right? You're gonna got something like this, and that is, and to 100 and 1100. And for sure this is more smaller, for sure, right? Then we keep going, multiply by 10 and 10. Finally, you get back to the value of 1,100, and keep the step, keep the step until you reach the maximum. That means you reach the maximum value here. So you must stop. You reach the maximum value, you stop and move on to the 2. What does it mean? Uh, it's like, you know, I'm sorry. You must move to this, right? And this and this. That is, what does it mean here? When you reach maximum, you must uh, um, absolutely you must remove, try to increase, but it's much smaller. So you're gonna remove the last element, if you got this. If you increase, you got the 100, 1001 is larger than the n. We must remove 0, remove it. You got something like this. Remove it, and like you when you reach these 2 digits, you can increase it. So the algorithm here is like you in each step, we multiply by 10 and push back to the answers and multiply by 10 until we reach the maximum, the limit. After that, we increase by 1 every time until you meet the 0 at the end. And all we need to do is remove that 0 to get the smaller lexicographical number. And after that, we keep multiply 10 and increase and do it so and forth until you reach the maximum. When you reach maximum, remove remove it. Just remove remove the last. Okay, remove the last element until you meet some non-zero. What if I say we're gonna got some limit like this, and you if you reach it 100,000, you got this and got this, and now you reach the maximum. So just erase this, erase the last element, and if that is to 0, you must erase too. But if we got something like this, so that's we remove the last element, in screen until we got 109, 1109, and it's become this. So as usual, you remove the last element and then multiply by 10, and you got this value, and increase, and now you can see you reach the maximum. What you do next? That is to move to the next value. That's 1,000. That is 12, right? You must divide this. You got 100, 111, but actually we got 111 before, right? So we need to divide it. So we're gonna divide this. We got 12. Oh, yes, we made it before. Yes, we made it before. So what we're gonna do to detect if we made this character before? It's the top questions. Oh, I mean, just increase by 1. Just increase by 1. You remove, got this removes, because something like this. And actually, we go to this, right? Go to this. This is more smaller, and keep going until you with something like this. And actually, it's time to move to 12 and then 10. Okay. So after some experiments, I found a solution that just follow from one, answers why the answer sign is larger than n? Because we know the answers must be exactly n. Size of the answers is exactly n. And like the q number, you can use the x plus and process back to the answers. Um, so if equals plus 1, if h is like less than n, multiplied by 10 as usual. Yeah, multiplied by 10 to else. That means we love it until we do this multiply by 10 till we reach the limit. And if nothing happens, just increases, right? And push to the answers, push back to the answers, put that value to the answer. Um, if like if it does like while 0, or as I said before, if we reach the maximum value, we need to divide by 10, remove and increase. After that, we increase the value and push back. Oh, so that is the solution. Wait a minute. Increase. Sorry, with 10 is also less, and it's not exist the limit n, so we keep multiplying. Let's see what time limit exists. Which last one? And divide. Oh, it looks so correct, but actually, what happened? What happened? Let me see. I see. I see. We must increase this first. No, no, please. Multiple, and then we increases, increase, and increase, and something we got new number by as is. Oh, just the button. It look like this conditions is never come true. I just don't know why this time limit. It's look like this equation always true. What does it mean? Out 1, then we got 2, and equal to 2. This looks so correct. What does it mean? Just wait a minute. Two. So it should stop. Answer sign and I just don't know why it's in time limit. Why time limit? It should stop, you know? Actually, I don't know why it doesn't stop. Just like Wait, like that. Actually, I don't know why it doesn't stop. I don't know why. Honestly, this one. Actually, I don't know. Actually, for real. I should just keep going and go out something like this, and we need to uh, divide it. Yes, if each large than or equal large than n, so we divide it. Yes, divide it. And we got like 1, but for sure we need to increase this again. So that is okay. We got it. Okay, submit. 100%. That is. So I know the idea. Again, I will say it more succinct as possible. That's when you start with one, you know that one is can go after that is 10 and 100 and 1000. You put 0 to the back is almost smaller than put 1 or 2 to the back or increase it from 1 to 2, right? So we just multiply it until we reach the limit. That's the end. Else, just increase the last element, increase by 1, the last digit, increase it, and until you reach something like 110. At that time, you not should not go to um, sorry, like 100 and 1010. At this moment, you should not move. Like you can move to uh 111. Okay, it's okay. But before you move to I mean like that here, let's see here, if the condition here, like you reach at example 110 here, if you reach 110, it's the max, it's the maximum value you can reach, so you must move to the next available smaller lexicography orders. That's the 100, like is 11, right? 11, and you know you meet some sorry, let me try again, explain it clearly now. Okay, as at beginning we got one. Obviously one is the smallest. Let's go graphical order, and then we got 10 and like 100 or 1000, because we put 0 to the back, the only way, the smaller way, the smallest way. Yeah, then you just multiply by 10 to put the 0 to the back until you reach the limit, right? Else you increase the last element. For example, you got 1, 10, 100, and the next must be 101, right? It's obviously, and 102 until you got 110. Obviously 12, 11 is smaller, because you remove the 0 and you got a smaller one. Yeah, so you keep removing the last 0, you got a smaller one, and it's never appear before in the list with the list answered. Okay, so after that, um, keep the repeat the multiply by 10, like you got 110, you remove the 0, you got 11, and you must, after 11 you put 0 to back. Obviously you got the next, that is 110. But after that you reach the limit, right? You reach the limit, that means you must go to the next number, that is 12. That's right, 12. 100 and 10 divided by 10, you remove the last element, remove the last, and try to increase the previous digits. That is 12 and 11, so we got 12. Obviously after 110, that is 12, and after 12, that is 100 20s and right here, and so on and so on. You got this solution. Okay, I hope my explanation skill is maybe not good, but I hope you can understand it. So have a nice